And now I'd like to welcome Dr. Georgia Khatib to the stand. Georgia is an Assistant Director, Research, Data and Projects with the Commonwealth Government Asbestos Safety Eradication Agency. We all know them as ASEA. She has over 7 years regulatory policy research experience in the Australian public sector, focusing on the critical appraisal and synthesis of diverse data for risk assessment in the chemicals management context, or for the informing policy decisions. This work has delivered recommendations covering work, health, safety, public health and the environment. This is underpinned by a PhD in medicine and a 15-year career as a medical research scientist, both nationally and internationally in academia and the pharmaceuticals industry. Her roles have consistently involved working in multidisciplinary teams and using analytical approaches to investigate complex issues, to deliver evidence-based information for informed planning and decision making. So welcome, Georgia. We're really looking forward to hearing from you today.
Okay, thanks, John, and good morning, everyone. I'm really happy to be here too to share a little bit about the research that the Asbestos Safety and Eradication Agency is currently undertaking. A few slides in. So firstly, just a little bit about the agency. We are not a regulator. We were formed following a 2012 whole of government review, and this was to oversee the implementation of the Asbestos National Strategic Plan. So this means we're responsible for coordinating national actions to improve asbestos awareness and the effective and safe management, removal and disposal of asbestos. We also seek that priorities and strategic actions across all jurisdictions are working towards a shared purpose. So Commonwealth, state and territory governments have agreed to implement the Asbestos National Strategic Plan, and this has an aspirational overarching aim of preventing exposure to asbestos fibres in order to eliminate asbestos-related diseases. So as Sharon mentioned, it's no surprise to this audience that the deaths arising from asbestos-related diseases are sitting at around 4,000 per year. And as Sharon mentioned, this is, we're saying now 4 times the annual road toll. So you hear about the road toll consistently, not so much about asbestos. So these deaths are driven by the estimated 13 million tonnes of asbestos-containing materials that were dispersed into the built environment. So our agency has a number of legislative functions to address the asbestos legacy in Australia's built environment, including our research function, where we commission, monitor and promote research about asbestos safety. Our research is focused on the 4 priorities as they are listed in the Asbestos National Strategic Plan, and these include awareness, identification and management, prioritise removal and safe disposal, as well as international actions. And today I'll focus on these central 2 priorities. So this slide just gives you a bit of a sample of some of the research that the agency is undertaking in these priorities. So for identification and management, our focus is on legacy asbestos in situ, in particular in the residential environment, and how we might manage this legacy. So this includes work on the National Residential Asbestos Heat Map, improving asbestos disclosure at the point of sale or lease, and also investigating technologies for real-time and accurate asbestos identification and testing. In the prioritised removal and safe disposal space, we're looking at things such as the asbestos stocks and flows model, looking at the quality, accessibility and consistency of asbestos assessments and registers, and also an analysis of illegal dumping reduction strategies. So I'll now provide you a little bit of extra detail on the research items marked in bold. So moving on to a key piece of research, the asbestos stocks and flows model. So I've alluded to this previously. We've developed a national model that provides best estimates for the how much of Australia's hazardous asbestos legacy is remaining in the built environment and the rate at which it is being removed. So modelling using, well, so outputs from this model tell us that As asbestos-containing stocks peaked at approximately 11 million tonnes in 1980. And as I indicated previously, overall, we've estimated that 13 million tonnes of asbestos-containing materials were put into the built environment. Recent estimates show that we estimate around 6.4 million tonnes of asbestos-containing materials to still be remaining in the built environment, and flows to waste are forecast to peak at approximately 167,000 tonnes in 2030. So I note that this model's estimated flows to waste does not incorporate asbestos-contaminated soils and rubble, and so estimates from this model would differ from other waste reporting totals that you've probably seen. This graph is just another way to show you this research. So this takes us through the estimated stocks across the entire time frame of this model, starting from 1920 to 2100. And you can see here that asbestos-containing material was entering the built environment at an increasing rate up until the 1980s, and then started declining thereafter. So passive decline of stocks is predicted at just above 10% per decade. And so without significant intervention, stocks are estimated to hit around 1 million tonnes remaining in the built environment by 2060. But you can see there's a long tail continuing beyond that. So moving on to the National Residential Asbestos Heat Map. Here we are using AI technology for the first time to find solutions to manage Australia's residential asbestos legacy. Now, the residential asbestos legacy is known in broad or anecdotal terms, we see that AI can fill the gap in asbestos data and information to give us more informed, more knowledge around what the actual extent is. So this approach we consider to be more time efficient and cost effective than traditional asbestos assessment and testing home by home, considering the more than 9 million homes in Australia, and the proportion of those that could be considered to have an asbestos risk. So anything built or renovated before 1990. So I want to point out that we don't see AI as a replacement to asbestos assessment and testing. It's something that is a complementary methodology that can be used to inform each other's approaches for improved efficiencies. So the overall aim of this work is to meaningfully compile all of available asbestos data and information in the residential environment in a centralised format. So currently any limited data and information that exists is dispersed and in disparate ways. And we want to use technology to maximise the value of this data and information to fill in the gaps using a non-invasive approach and expand our knowledge. So the way that we're attacking this is using a research plan with a systematic approach and starting with what is feasible. So we have recently completed a proof of concept AI study looking at the detection of asbestos cement roofing in the residential environment. We're scoping potentially using the technology that was developed in that research project to see if it can apply to detecting asbestos in remote Indigenous communities. And ultimately what we want to know is, predict the likelihood of asbestos being present or absent in the whole of the home. All these research pieces together will inform the National Residential Asbestos Heat Map, but also what's coming out of the heat map will go backwards to inform where we might want to focus individual efforts in any of these spaces. So this is just a short video which shows you the methodological approach used for the asbestos cement roof hotspot study.
A residential asbestos roof hotspot mapping project delivered by ASEA and ASEA uses big data and artificial intelligence to detect asbestos roofing. The model detects asbestos roofing hotspots across Australia and identifies asbestos at a property level. Residential detached dwellings and outbuildings with asbestos roofing are detected. Developing an evidence-based national picture that assesses the likelihood of asbestos-containing materials being present in the residential environment.
Okay, so just to reiterate, so what we did there, we used urban analytics to identify localities that were predicted to have asbestos used in the residential sector, and for that asbestos to remain. So the type of criteria that we used in this initial ranking were socioeconomic, demographic factors, and building development criteria. So the top ranking localities from that analysis were pre-screened by an asbestos assessor to identify localities specifically enriched for corrugated asbestos cement roofing. We chose that type of cement roofing because it would be an easily detectable type of material for the technologies that are available. The AI model was trained to detect asbestos cement roofing, and this, as I said, was a small-scale study focused on just 770 square kilometres across Australia. So we successfully achieved that and proved that AI could be used in this space. And the results were packaged in a stakeholder resource kit and shared with the jurisdictional stakeholders that are responsible for implementing the Asbestos National Strategic Plan. So what we delivered were fact sheets focused on each jurisdiction, highlighting the overarching national results, as well as local information at the state and local government level for each state. We also created a report on the residential asbestos cement roofing legacy, really just to give some context to that issue, and provided a brief history of asbestos cement roofing in Australia, including what we understood from early importation and manufacture and how this evolved with increasing demand and then the tailoring off. We've provided as much information as we could identify on product types, how they were consumed, where they were used, and risk profiling, and also offered strategies for managing legacy asbestos cement roofing that could be applied in a systematic way. So as I indicated in our research plan, what we're currently scoping now is whether or not the technologies that were developed in that roof hotspot studies could be applied to advance the identification of asbestos in remote Indigenous communities. So we're currently consulting with the National Indigenous Australia's Agency to scope the use of this technology and potentially expanding it. So looking at using Google Street View to detect external asbestos cement cladding where this imagery is available, and using the same approach, so the aerial and satellite imagery to detect asbestos cement roofing, as well as potentially illegal dumping. And to the right here, you see some images of how AI can be applied to use Google Street View images to detect external asbestos cement wall cladding. So overall, all this is work going towards the overarching national residential asbestos heat map. So what we want to do here with all this work is develop a first national map that shows the likelihood of asbestos containing materials being present or absent in the whole of home. This research commenced in November last year, and we're working with consultants from Tetra Tech Coffee, as well as from the University of New South Wales City Futures Research Centre. So the National Residential Asbestos Heat Map will be based on several input data sets that have been shared with us from government and non-government sources, as well as internally generated data. So we've managed to obtain a limited amount of commercial asbestos assessment data. So this is lab testing or expert opinion on samples taken or observed in the residential sector. We've also received government data in terms of the status of asbestos in either public housing or other housing that is owned or managed by governments, and this has a wider spread compared to the previous data set. And of course, the research data like the asbestos cement roof hotspot study, as well as I hope some of you are familiar with the Latrobe Valley Asbestos Task Force research. So we're expecting the first national residential asbestos heat map to be complete by around the middle of this year, and we'll be working with our jurisdictional stakeholders on how we can share that information with them and how it can be used. So moving on to technologies now, and really looking at potential innovation for real-time and accurate asbestos identification and testing. In 2021, we made a successful submission to the Business Research and Innovation Initiative, or BRI, Regulatory Technology Rounds, or RegTech Round. So this is a program that is administered by the Australian Government Department of Industry, and we invited small and medium enterprises to put forward innovative solutions to address our challenge of asbestos identification and testing being done accurately and in real time. So we we suggested that solutions could cover any of these areas here. So digital solutions, imaging, software, mapping systems, anything that would improve the current situation. And the aim was to test ideas that would make the identification of asbestos not only more accurate in real time, but also less burdensome overall. So this is just a schematic on how this program works. So as I said, we proposed our challenge. Our challenge was accurate identification and testing of asbestos in real time. Small and medium enterprises apply to address the challenge by proposing solutions to this. And through a peer-reviewed process, a number of these applications are funded for a feasibility study. So we're currently in these 3-month feasibility stage, and then following this stage, successful applicants can proceed to a proof of concept stage where they'll obtain additional funding for a longer period of time to fully develop their ideas. So at the end of this entire process, the agency that proposed the challenge or the Department of Industry itself can purchase these solutions, or the small and medium enterprises can go on and sell their solutions worldwide because they own the IP that they're developing in this. So the successful applicants for ASEA's challenge are listed here. So some of these you might be familiar with, so this includes the ALERT, real-time monitoring and warning device for airborne asbestos, as well as the microphaser, so which would offer in situ testing for 6 types of asbestos in bulk and airborne filter samples. But we've also got some technologies that are a bit earlier in the pipeline, including from Flawless Photonics, so a hand-portable in situ real-time non-contact asbestos sensor, as well as from the Predictive Analytics group for testing technology, microwave technology for in situ detection of asbestos in wall panelling. The final successful applicants is UAX Consulting. So this was the group that we worked with on the asbestos cement roof hotspot study. So they put forward an idea for developing an app that they've called Asbestos Vision, and that's to help homeowners identify asbestos and connect them to the right people to handle that. So the professionals essentially. So as I said, these projects are in their, they're in the 3-month feasibility stage. They're heading towards the last few weeks of this stage. And if any of these are successful to move into the proof of concept stage, that will commence in October this year for a period of 15 months. Finally, I just wanted to move on to some recently commenced work on asbestos assessments and registers. So Australian work health safety laws don't mandate how asbestos assessments describe or grade identified asbestos, and this can have flow-on effects on how the identified asbestos is managed by PCBUs. So we're exploring different avenues to address issues around quality, accessibility and consistency of asbestos assessments and registers. And we're looking at working with various people already in this space. So with Safe Work Australia, we hope to collaborate with them to develop a pack of supporting material, including guidance on risk assessments of asbestos and potentially case studies on effective asbestos management in support of the Boland review of the work health safety laws, where they're already developing additional guidance in this space. We're also consulting to better understand the VAEA's model of risk assessment and whether or not that can be applied more generally in other contexts. And internally, as part of our own disclosure of asbestos in residential properties, we're developing some guidance to assist homeowners to understand the importance of identifying asbestos in their properties and what their role is in asbestos safety. So as Sharon and Philip also indicated, working with you is important to us. Your expertise is valuable. We're always seeking for contacts to share technical advice or for us to seek advice from in terms of the different pieces of work that we do. And, you know, this contributes to the ongoing research that the agency is undertaking. So I'll end also with some contact details here, but I'm happy to speak with anyone after this meeting, as well as at our upcoming conference that you might all be familiar with in May. So, yeah, thanks.
Question for me. Have we had any updates on how the actual handheld devices and the realtors are actually progressing in their initial trial stages? Is there anything looking promising at the moment?
I don't have that information, but we have final presentations with all these groups coming up in May, and we are there will be an audience for these final presentations, and so we'll hear what the final outputs are in there. Unfortunately, I'm not involved with all the projects, so I can't give you an update.
No, thanks for that.